the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. At the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
Thank you, everybody. Thank you to Professor Sarkar for letting me be here. So I'm going to talk to you guys. I'm kind of trying to tailor this presentation to what you guys know. I like to keep it pretty conversational, so if you have a question, feel free to ask. I might want to finish a point, so I'll just tell you to hold off a second. But yeah, just feel free to jump in. I want to get to about 45 minutes through the presentation and then kind of open up just to questions and answers. I like to get engineering background. I like to get pretty deep into the details, but if there's something I can't answer, I'll get your contact info and I'll try to get back to you on it. So the whole kind of thesis of what we want to talk about is, looking at urban farming and how it kind of is growing up. So AeroFarm is all about indoor vertical farming, and I'll get into what that means and what are kind of the limitations of it, what are the advantages of it, what's kind of like the reasoning why vertical farming has become a pretty kind of interesting proposition for investors, for policymakers, for kind of for entrepreneurs going into the future. So thanks for being here. Hope you guys hang on for this. First, I'll just go a little bit into about me. Don't really like talking about myself that much, but I think it's kind of, especially working in a startup context, it's good to know kind of how I got to this point. And then I want to go into issues in agriculture, kind of the basics of vertical farming, and then kind of going into how AeroFarms was built and how it was started. And then next steps and any resources that I can direct you guys towards if you want to learn about more, and that's kind of going to be our Q&A section. I worked, like Professor mentioned, I kind of graduated, then had this kind of tremendous opportunity to work with Bill McDonough. If you guys don't know him, he was the kind of visionary of cradle to cradle kind of systems or kind of philosophy, really. Then I got to work for Turner, went to AeroFarms for a while, and then now I'm back at Columbia for some reason. But I'm currently working on, I saw kind of like the policy case for urban agriculture, so I'm actually working on the comprehensive strategy for urban agriculture for New York City that's hopefully going to get voted on by City Council in July. So yeah, I mean, but going forward, like, I'm just happy I graduated at first. So back in February of 2014, I had already been with the company for 3 months or so. This is what our org structure looked like, kind of, really small. And so there was me and the marketing director doing pretty much all the work because, executives do what executives do. And then kind of going forward about 3 years later, so on the picture on the right is kind of showing where we started. We were in an apparel store in Newark, kind of just building our prototypes from scratch, kind of figuring out like how we can use the space to, be like a really narrow aisleways and kind of help us out. So 3 years later, this is what the company kind of org structure looked like. I never actually got promoted technically, kind of stayed where I was, but I had about 50 people working under me. So I was the plant manager at the time that I went back to school, and about half the company kind of reported to me, which means that I had to kind of deal with a lot of HR issues, kind of had to figure out, start those processes from the beginning. Kind of these were all the jobs I had over the time, yes, including janitor, yes, including trainer, did a lot of budget work, did some construction work, and did some CAD modeling. So enough about me. Anybody know who this guy is? Yes? No? Okay, well, you might not know it. This guy kind of really revolutionized the way that we do agriculture nowadays. So you might have heard of the Green Revolution, and especially in India and Mexico, it allowed us as humanity to really improve the yields of our crops, cereal crops, especially wheat, and that kind of, his methodologies kind of moved into corn, into rice, and what Erie did, IRRI with rice. So it really allowed population to kind of explode. So today, or back when he won the Nobel Peace Prize in 1976, he was a hero for kind of allowing us to, you might have, as sustainability students might have heard of, the Thomas Malthus kind of problem about how we're not going to catch up with, or how we're going to run out of space to grow our food and with our resources. He kind of broke Malthus, but at the same time, nowadays he's kind of being seen as a menace a little bit. So because he prioritized yields and production over kind of ecological sustainability, ecological preservation. We started using pesticides, more fertilizers because of this guy. So the realities are, by 2050, we got to feed 9 billion people, and the other realities are that our yields that we have currently aren't going to keep up to that pace. So the dotted lines on the map are on this graph here are where we have to get to in order to kind of feed people by 2050. The solid lines are where we're at, or where we're kind of projected. So no crop is really kind of close to that. Corn is the only one that has a chance. If you kind of look at those gray, or those like lightly colored fields, those are kind of where the variance in these studies are. So that's one of the main kind of issues with kind of creating, keeping developing our cereal crops going forward, but there's also other things. So more compounding factors. Yeah, these are pretty, splotchy, daunting maps, but on the top right, the main takeaway there is that we are, as we're expecting our global temperatures to rise, our yields are going to decrease dramatically, especially for wheat in India and corn. And then going down, you guys might recognize this map. This is a drought in California. And there's, especially in the Central Valley, that was where a ton of our food is grown. And moving to the left, as we've relied more on pesticide usage, glyphosate, atrazine are kind of like the main pesticides that we currently use today. They've kind of reached unprecedented levels of use. And then moving up is like soil erosion. So that's another kind of big issue in the U.S. There was a really kind of scary, gloomy study from, I think it was Scientific American, that says we have only 60 years of soil left on the planet, which means that, so in about 60 years we're going to kind of run out of soil to grow the foods that we have because of erosion, because of our constant, and so all these kind of factors kind of have created the case for why we want to change the paradigm of how we grow food today. I've kind of circled these areas because of the Central Valley. The Central Valley has kind of been at the heart of a lot of these issues between erosion, between pesticide usage, and drought. And so kind of looking at the basics of what urban farming is, pretty much it. You kind of take a wider piece of land and you kind of stack it as much as you can. But there's an issue. We got to add water, and we got to pump water up, so we have some sort of electrical usage there, some sort of energy that we have to put into the system to get water up to the highest level. And then, even the sun kind of is great for growing our crops, but as you get to kind of vertical levels, you start to kind of get shadowing effects. So we got to add artificial light. Oh, what does that mean? More energy, more light. And also we have the other main issue of outdoor farming is you can't control all your variables, so you have birds, you have pests, you have all these other things, so it's just, put it indoors. So on top of that, we have to now control this space. Plants have a very narrow band that they want to live in, but on top of that, some of the benefits are, we have added benefit in food safety. So this is just kind of the basic unit model of what vertical farming is. And so this is what it looks like in theory. So this is back in the early days of Aero Farms. We kind of had our architect help us out with some rendering. So this is what it is, but this is what it actually looked like when we built it. This is another shot here. So imagine like a warehouse, kind of just full of plants, full of light, full of kind of air rushing around, full of water going up and down. So all of these kind of stacks of light and whatnot can kind of be broken down into some pretty simple principles. So we have, for every level, we have some LED lighting that puts light on our plants. We have an aeroponic mist in a chamber, and then I'll touch more on that. And then we also have a cloth growing medium, so no soil that we are using, and that's also reusable, and it comes from recycled PET. So with the aeroponic mist, obviously we have some water so you might have heard of hydroponics. So that is kind of a constant bath of water. So in aeroponics is really like a mist of water, just a high pressure kind of jet of water that goes in, and then it gets recirculated. So every tower that you see here has its own water reservoir, its own water system that we kind of maintain. We adjust the nutrients as these plants grow, and they all have kind of different scheduling systems. So by using these three principles on the right, we're able to kind of we're able to create a system that uses no soil. We can stack all of our growing systems together. We can recycle our water, reuse the medium, and have a discrete growing unit that we can schedule independently. So what does Aero Farms actually grow? We have kind of baby leafy greens for retail. Whole Foods in Newark and other ones in the area, you can buy them at. You can also get them all fresh direct if you want to. Just kind of like arugula, kale, romaines, mixes here and there. But the main reason of why we grow lettuces as opposed to other kinds of vegetables is it's a pretty big market and it's growing. So we've seen salad joints kind of open up left and right.
Matt has a question.
Yep.
Could you go back to the other slide, to the previous slide?
Mm-hmm.
When you talked about water recycling and pumping water, you're pumping water from the bottom and going up, right?
Yep.
So can you utilize rainfall from the top and bring it down so that you're not using energy to pump water up?
Yeah, so that's a value added thing that we're looking at. The one thing that we need to do is get high enough pressure, so we're kind of operating at pretty high pressures, more than what your kind of tap water is coming out at.
A lot of head.
Yeah, a lot of head pressure. So and also water is heavy too. So to get the head pressure that we want to, we're going like 100 some feet in the air. So we're at any kind of rate, we're doing kind of pump assist for our misting. But yeah, that's one thing that we looked at, and we would have to definitely beef up our structure a lot just to be able to hold the water, which kind of like in some ways defeats the purpose. So you get kind of, I'm working on a project now to centralize all the water systems and kind of take it to the next level. But yeah, that's a good question. So yeah, but yes.
What did you say the cloth is made out of?
So the cloth, it's polyester, but it's all recycled kind of PET. So water bottles like this, our vendor kind of makes it into this polyester fleece that kind of you see on stuff in like Patagonia and whatnot. So going back to why we grow lettuces as opposed to other things. The market is pretty big and it's growing, and we can get from a seed to an actual package under the same roof in about 18 days. And lettuce compared to other things is a much higher dollar per pound kind of proposition. Definitely more so than potatoes. Definitely more so, and it's much more stable across the year. So what you're paying for lettuce now, you're probably paying for in the summer as well. And lettuce compared to other, like on the biological side, compared to like fruiting plants like tomatoes, you're using a lot less energy to get them to the sellable point. So you're just eating the leaf as opposed to waiting for an entire fruit to kind of grow. And that also has different light and nutrient profiles that is required. But this allows us to do year-round production, and growing indoors kind of really reduces our chance of contamination. So you guys might have heard in the news, recently having whether spinach or lettuce contamination through E. coli or norovirus. So, and I'll get into that because 22% of all foodborne diseases come from lettuces and leafy greens. So this is from the CDC, and that's #1 across all food-related items. So AeroFarms is able to put that under a roof, kind of have a traceability cleaning there. Land use, so in the United States, we've seen a 17% decrease in arable land. That's a lot because of suburbanization, some of it because of erosion. And so we're 4-to-1 ratio of growing area to floor area. That's inclusive of all the aisleways, of all the kind of service spaces as well. Water use. So check this out. Half of all of our lettuces are grown in one county in California. And California has 80% of all lettuce production. The U.S., what we eat here has 95%, and then we kind of not subsidize, but import from Mexico during some of the winter months as well. But usually kind of moves from California to Arizona back. So we're looking at a drastic reduction in water usage, and especially in California, where they kind of stopped relying on kind of reservoir water and started pumping groundwater, which leads to its all host of issues like land subsidence and that's our emergency store of water. We kind of have started cleaning that, especially in the Central Valley. And then food miles really is the bigger proposition as far as a locally grown item. You got about 3,000 miles from Monterey County, which is where we are to here, and that doesn't include any kind of stops for distribution along the way. And for us, we have one truck that kind of goes around and does a 100-mile loop and delivers to all the Whole Foods. Obviously, it's a very, very small operation. We're looking to grow in our full facility, which I'll get to, about 1.5 million pounds a year, which sounds like a lot, but a lot of the growers in California do over 1 million pounds a day. So we're really not. We're just scratching the surface at the market, which is why we're able to operate in such a pretty large capacity relative to just kind of the regular system. So now, what my kind of role was looking at how to improve revenue and reduce cost. So kind of very engineering, businessy kind of things, but the real main thing that we were trying to improve is our tray yield and also our utilization. Like how efficient can we be with getting our plants through the system? But against that, we have to kind of account for labor, our utilities, electricity and water, our raw materials themselves, so like the seeds, the packages, and our waste stream also. So lettuce has about I've seen some things be as high as a 50% waste stream before it even gets to the actual consumer's hands. So we're losing stuff at the store, we're losing stuff at the farm in distribution centers, and then also we're have a wealth of real estate. So some of my recent kind of research shows that we have about almost 4,000 acres of vacant land in the city that could be used for farming potentially, but we're not using it. So, but the main thing for indoor farming is to do adaptive reuse. So using a building that's been there. So I'll go kind of into the origin story. Anybody have any questions up until this point? No? All right. So I'll kind of go into this little sub-agenda, kind of how we designed the building, how we created the process, how we currently manage our performance, or started to manage the performance, how we started to manage our data, and the people as well. So our employees and the information, how things get passed from one person to another. So this was where we started. So if you, it's probably not there anymore on Google Maps, but this was an old kind of iron foundry, or steel assembly facility that was around during World War II. And this was, on the left, the photo I took the day before it got knocked down. So, and I'll show you real quick. So this whole area here kind of got knocked down, and we kept that building over there because it had the sound structure. So this part here, despite it looking pretty good, it was all kind of rusted out and rotted out, and we had to unfortunately dispose of it. But it looked pretty cool, and this is what we got in return. So this is kind of turned opposite direction from that initial photograph, but where the part that we reused is in green and then kind of built a building around it. We actually haven't finished this part yet, so we've kind of built this green part and then over here, so this front part as well. So I think that's part of the realities of being a startup and dealing with investors, where they wanted to de-risk as much as possible. So they kind of set us up into phases, and so we're about to close on the next phase and building out the rest of our facility, which means we're gonna more than double the amount of growing towers that we currently have, and kind of get to that 1.5 million number that we want to. If we take this view over here on the right and kind of go to the top, so we have certain functions in this building, and going back to what I talked about before, we really wanted to maximize the capacity of growing that we have in the area. So everything that's in green we kind of planned as growing towers. So most of the space, about 2/3 of the space, is dedicated to growing. What's in blue is for offices to be built later. So we currently kind of have a satellite office and then a tiny farm office. But everything else in orange are all the other functions of the farm. So we had to figure out pretty much everything from where we have bathrooms to where we put our seeds when we're storing them, where people actually sit in break rooms, where we're doing all of our seeding and all of our packaging and ancillary processes. So this is where I would say having kind of a little bit of operations background kind of helps in terms of understanding what you want to achieve. So we just kind of started mapping out our process. So we're going from seeding all the way down to shipping. How do we get from something that's in the door as a seed and then taking it all the way out the door as a finished product? So this is high level kind of overall picture. So every little tile that we have here has its own sub-process, which has its own sub-process, which has its own procedures, but you can see there are a couple things that are similar to what a normal farm does. So we have the growing, we're doing quality checks. We have kind of like a reject loop over there, and we are harvesting things, we're mixing them, packaging them. The things that are kind of different from a normal farm is, we have this cleaning step of our medium, so we are able to bring it back into the seeding area, and we also have this kind of loading and unloading kind of step, which is actually putting the trays onto the towers. So it's a physical step. You got to get it from one place to another, and then kind of taking a look at a little bit further. So each of these steps, like I said, have sub processes, and we wanted to be. I know it's a cliche, but big data, right? We wanted to kind of have a way to capture all the information of a single tray and tell its story all the way through. So who seeded it? Where did it go in its germination step? Which tower did it go into? How well did it grow? Were there any steps along the way that we could are there any lessons that we could have learned from that tray as it grew to help us improve in the future? And that involves a lot of information gathering, a lot of data collection. So pretty much on the left is kind of in big buckets the questions we wanted to ask, and on the right is how are we going to get that information? Are there any decisions along the way that could have helped us make those decisions? So and just going back from here, we kind of mentioned that we have all these processes, we have all these functions that we needed to do, and this is kind of what we ended up with. And so this is a very kind of a very dense area, very active area, but it didn't really just drop in on its own. It kind of had a lot of iterations, a lot of teamwork, a lot of collaboration, a lot of stakeholder interviews. So we kind of started with the main sketch. We kind of worked our way to a couple different ways of kind of modeling the space. Used a lot of 3D modeling. Anybody here familiar with SketchUp? Yeah, I would say SketchUp is probably it's a great tool to use because it allows you to kind of communicate, to kind of like show a quick model to somebody who is able to not, who isn't really like inclined for kind of visual stuff or 3D modeling. Yeah, you can get models done pretty quickly, and it works pretty well over the web. So I first learned how to kind of use it effectively when I actually worked with Bill McDonough. We were doing kind of like remote modeling with SketchUp about certain ideas. Kind of took that concept over here, and I would say it's probably a good tool for everybody to at least kind of pick up and use, even if you're not going to do anything physical in the future, but it's something to kind of understand that everything that we do is going to have some sort of physical element to it, and it's going to have a process to it, and being able to kind of, sometimes even a picture or a diagram can't do it, sometimes a quick like 3D representation will help out a lot. So going more on the software side, so we then, actually I'll go here first, so we then, oh nice, they popped up, kind of needed to figure out, all right, we got these trays, so at this point we had over 2,000 trays growing in the system. How are we going to schedule them? How are we going to maintain our high utilization for the facility and not overload our operations on one day and then not be able to harvest everything that we wanted to and get the work done? So we had some constraints there with with labor, with the physical space, with our equipment. So we kind of went into a deep dive mode on understanding the best way to schedule everything and keep our utilization high. So on any given day, we have, let me go back here, all of our kind of trays entirely filled. And then so our goal was at the end of the day, make sure everything is filled, everything is growing on every kind of level. And the only way to do that was to, just really kind of create an algorithm that allowed us to do this queuing function. And that kind of interfaced with a main database, and on the other side we had our kind of growth models. So understanding what inputs are going into the system in terms of water, fertilizer, light, air conditions, where we can hit that sweet spot for maintaining a high level of growth. And then using a sensor system, which I kind of, on the bottom right is kind of showing how all those things kind of mesh together. The one thing in the center over here, one box in the center is kind of like our main database, and how all these elements kind of tie into that, and kind of how crucial it was in order for us to grow properly, in order to schedule things and get the work out to our team. And then on the left side is on the R&D side, how are they actually able to figure out all of these different elements? So on the bottom left just kind of shows just a kind of a little result of how many, like we have a kind of a certain range of leaf sizes that we wanted to get to, which kind of correspond with like weight. So we wanted to maximize how much weight we get within our certain leaf size. And then those parameters get fed into the database, which allows us to grow a little bit more optimally than before. So all these results that we get from our harvest, the idea is to be able to feed them in as like a machine learning. That's another cliche word, but a machine learning kind of element that we get higher and higher yields from just understanding our process all the way through. All right. And then, so at the end of the day, though, people have to do the work. Machines can't do it for us. So understanding all the ways that information gets traded through the system, where we start from and where we end up is important. So sales has a pretty big influence there. So sales puts in a certain amount that they want on a certain day, and then we have our scheduling algorithm that then kind of spreads the information far and wide. Creates work instructions for all the teams that need it, and then for all of our, and then all that goes into a new inventory, a new dashboard that the executives can look at, and they can be like, hey, we're doing great. But further than that, like each of these spaces had to kind of get taken a look at with a pretty heavy-duty microscope. So I'm going to cover one of our functions that we kind of started at in the beginning. It's definitely changed since then. So I would say the biggest thing for getting if you're working at a startup or really any company, is don't settle for your processes. Don't kind of make something up and then realize that, oh yeah, this is good enough. Always kind of keep looking to improve. And so this kind of system has kind of changed around 3 or 4 times since this current rendition, and that's kind of a testament of getting information from your team, getting information from the next step down the line, and then the step ahead of it too. So, but this is kind of before we even set foot in the building, we kind of wanted to have our whole process mapped out. And that's another thing too, is kind of be able to, if you're working on an operational process, think about what your steps are in order to, before you even get there. Have your answers and really have your questions and your unknowns before the process gets started up, so then you can kind of try to answer those on the fly, which we had to do. So we kind of set up all of our processes into the 4 Ps we call it: place, process, people, and paper. So where are we actually doing this work? How are things moving in the space? How are things getting in and out? And then what's the actual process of doing this? So where does information come from? What steps do people actually take? A lot of tree diagrams. So all this that you see here, and I'm going to back up a little bit, is kind of just represented in this first tile over here. So it's really kind of cascading kind of processes. And another big thing is for the executives that you'll be working with, they really care about high-level information, right? What do they need to make a decision? What do they need to worry about? And to be honest, I probably showed this to our CEO and COO. They didn't care. And not to say that they didn't care about the process itself, but for them, it didn't weigh for them as much as understanding where are the barriers in this overall flow over here. So I would say feel free to take the next step, keep asking questions, dig down deeper into processes, and and figure out where your kind of questions are and your unknowns are. And then people. So understanding who is the right person, what do they need to do. The one thing that when you're going to be working with teams is clear expectations are paramount. So being able to get your team to understand what they're doing, what they shouldn't be doing. And I had a great team that, especially starting up a process, kind of go in with the understanding of, hey, we're going to not know a lot of things. We need information. And the team was, they helped craft a lot of the work that they're doing today, and have been able to kind of take it from this level to something that is more efficient, less strenuous, and be able to kind of just have a more, dare I say, sustainable process. But it really comes down to understanding who has responsibilities in each step, who is kind of the overall lead, and what training they need. And safety training is pretty important. I think that, and probably like a lot of your CSR work, you've kind of like come across safety as a big aspect of corporate sustainability, and I would definitely echo that for sure. And then finally, paper. So at first, we had all this flashy diagrams and GIFs that we use for our scheduling algorithms, but at first, it really does come down to paper, kind of understanding, because this, especially when it's a kind of a personal, like a process that people are working on, they're going to know what information is efficient or is best for that, and you're going to make a guess. You're going to kind of find out, how many trays did we seed, how long did it take. There is such a thing as information overload, where you're kind of trying to track too much, and that's where errors come in. And if you're relying on a certain derivative piece of information, you're not going to be able to kind of get that effectively and you'll sometimes look like a fool in front of the executives. So it's really a good understanding of where, and again, constantly evolving this. So right now, we went from paper to we're using a tablet app that we have, and they just kind of put in the information as they need, and it's a timestamp whenever they kind of say, okay, we're done with this, and now the main database system knows that cart got done. It's going to know how long it's been in hibernation, because when we load it, we also have a tablet that we kind of say, all right, it's been loaded, have a timestamp for that. And then the next step that we're going to is RFID. And so it'll take essentially the human element out of it. We'll have RFID gates that when a certain trait passes, it'll kind of notify the system with a timestamp. And it's all about constant improvement, knowing your kind of process thoroughly of where you want to start and where you want to take it, and then continuing to develop it from there. So that's, I guess I kind of went through that pretty quick. That's all I got. Is any questions?